In the last video, I went through an example problem of how we can factorise using the difference of two squareds. But I do want to go through another example of this where our x term is actually the second term, because I often find that people just get stumbled a little bit when the x term is actually the second term when we're trying to use the difference of two squares. Let me give you an example. What if I was trying to factorise 25 subtract 9x squared? Now, it's easy to see that we can actually use the difference of two squares here because we've got no middle term of our quadratic and we actually have two square numbers, which is really nice as well. But our x term is no longer the first term. And sometimes people get stumbled on this of, well, what do we do when that's the case? Well, let's think more broadly about this. The difference of two squares rule can be written more generally as just the a plus b and a subtract b multiplied with each other, which when we go to expand this, if we use our FOIL, will be a times a, which is a squared, a times negative b, which is b subtract ab, b times a, which is ba or ab, so plus ab, they're the same thing, and then b times negative b, which will be subtract b squared. And as you can see, the middle two terms will cancel with each other, leaving us with a squared subtract b squared. Now what I did over here is I essentially went, well, let's let my a value equal ax instead and see what happens when I expand that. Well, we can do the same thing with our b value. Let's just let our b value be bx instead. So when I substitute into here, I can say that this here is essentially a squared subtract bx all squared, which when we expand that is the equivalent of a squared subtract b squared x squared, which then makes it look a little bit more like we had here, which makes it a little bit easier to play with. So what do we do with our problem over here? Well, we do the exact same steps as we did before. We square root each term essentially. So 25, square root of 25 will be plus or minus 5, but the signs don't really matter here, so let's just use 5. So this is the equivalent of 5 squared. Subtract, square root of 9 will be 3, so 3 squared and x squared. And what we can see here is we've got it looking like this. So now I can identify what my a and b are. My a is equal to 5 and my b is equal to 3. Now, what I do from here is I substitute it back into the original part up the top. Keep in mind that my b is now bx, not just b. So, my a is the equivalent of my a of 5 plus my b, keep in mind my b is now bx, so my b of 3 times x, and then my a again, so my a of 5 subtract my b, keep in mind it's bx again, so my b of 3 times x. And I've now factorised this by using the difference of two squares. But, like as we did before, we can check to make sure that this is correct. So, let's use FOIL here and expand this out. So, 5 times 5 will be 25. 5 times negative 3x will be take 15x. 3x times 5 will be plus 15x. And then 3x times negative 3x will be take 9x. And now I simplify by collecting like terms. So my 25 is my only constant. I do have two x terms, negative 15x and plus 15x, they cancel. And I just made a mistake here, x times x will be x squared, so this will be take 9x squared. And that's what will be at the end here, subtract 9x squared. So what you can see here is this is equivalent to this, which means that we've factorised this correctly. So in essence, you can apply this difference of two squared rules wherever your x term actually is. It doesn't have to be at the front. It can be the subtract the x term squared.